Professor Dot. So I'm going to give the first half of this presentation, and then unfortunately I have to leave to catch another meeting and a Zoom, of course, meeting. But Professor Dot is actually a tight collaborator on all these projects, and I guess he can also answer questions for sure. All right, so the topic of this talk is about, using wearables and mobile sensors for personalized healthcare. And I guess I don't need to emphasize the importance of these things anymore. Unfortunately, thanks to COVID, which has basically shown us that telemedicine and e-health is actually the solution, especially when we want to address pandemics and situations like what we are in. All right, first of all, I would like to thank our surf-IoT students, Aviv, John, Aviv, John, Yu Cheng, and Jonathan. And you guys doing a good job and keep up the good job. And so happy to work with Cal82 as usual. So the topic, as I said, is about wearable sensors, mobile sensors, and so on. And they fall under this umbrella of IoT. And this is basically a surf-IoT program, per se. And I guess this is the best place to share some of these the results of our research. So, but as you can understand a little bit from the beginning, we use and leverage IoT and technology mostly in the context of healthcare, because we know that there are plenty of other use cases and applications for IoT. So I'm gonna still a little bit, even though I know you guys are familiar with IoT, but it doesn't still hurt to touch a little bit quickly the role of IoT and the potentials of IoT in the healthcare sector. And then just to give you some examples, some case studies, we're gonna present a couple of the projects that we have been doing together with Professor Dot, some of them here in the US, some of them jointly with Europe. All right, so first, if you wanna basically know what else we're doing in our lab, feel free to visit our lab website, Health Sci Tech. Professor Dot also has his activities in his research group called Dot Research Group, or DRG. So in general, what we do is really end-to-end. So our research is quite applied, because I have my main appointment with the School of Nursing, even though I'm a CS, by training, I'm a computer scientist, but basically I do a lot of research in the healthcare domain and in real settings and dealing with patients. So what we do is actually very end-to-end, meaning that we need to take care of many different stages of our, basically whenever we build a solution, we need to deal with different aspects of it. Sometimes we design sensors, like wearable sensors from scratch. Sometimes we use off-the-shelf sensors, but we need to be able to work with the signals coming out of those, like doing some biosignal processing and so on. Oftentimes, when we are dealing with everyday settings, like patients or persons or people actually are out there living their own life, we need to be able to capture their context, their life events, and so on. We need to be able to run infrastructure, as we are talking about IoT. So we need computing infrastructure, cloud, edge, and so on, to be able to handle the data and perform data analytics, which actually is our next step. All these sensors that generate a lot of data, and without sense making, basically you cannot really leverage the potentials of these the data that you capture. So all the way also to the very end, which is smart recommendation and so on. So all these things in different projects that we work on are happening, and that's what we do, and that's what we call healthcare Internet of Things. So really end-to-end solutions. So then what is IoT? I guess for this group, it's kind of quite clear that IoT is actually the next generation of the traditional, the new generation of the traditional internet, which was basically the internet of people. And now it's becoming, or it has become, the Internet of Things, meaning that you're not anymore just connecting people to people, but you're connecting people to things, or things can communicate with people, or even the more ultimate version of that is when things communicate with each other. We also call this like machine-to-machine communication, or M2M technology. So these are all happening. I used to give this course on IoT like 4 years ago at UCI, and at that time I needed to spend a lot of time giving examples, but thanks to the technology, I guess we all have a lot of things these days which are connected to the internet and they're not traditional desktop or mobile phone. But the important thing, which is sometimes kind of neglected, is the fact that data itself, things only generate data for us, and we can do sensing using things. But the actual benefit is when we can do sense making, when we can basically process and analyze the data and go up towards this, basically the peak of this pyramid to really reach the wisdom. So that's why we're starting from big data generation, but then we need big data aggregations and actually reaching big data analytics. And that's why IoT needs to be combined, and different technologies like M2M communication and so on need to be combined with really kind of AI and data analytic techniques to be useful. So this integration of these two technologies is really important, and that's also what we do in our research in our lab. Giving you some numbers, it's always good to see what's happening around us. These numbers were before COVID. I think COVID has even increased the impact or the basically prevalence of this technology. So you see every year the number of connected sense devices are increasing. We're talking about billions. And the idea is that by 2022, 29 billion devices are going to be connected. And something I would like to show you is the contribution of short-term IoT devices, which is actually increasing very quickly. And many of the healthcare devices fall into this category, like Bluetooth-enabled, like ECG patch or a smart ring, and so on. Many short-range IoT devices, like 20% at the same time at this time. But just wanted to say that this is a very promising sector or part of this entire IoT, ecosystem. So we leverage and we try to use IoT devices, mostly wearable, or some of them are basically maybe in your living where you live. They're installed somewhere like there. Try to basically use those devices to form what's called a body area network or a personal area network, to be able to capture different things like your vital signs or lifestyle, your environment, and so on, and basically fuse all this data, usually through a gateway, which can be a smartphone, which can be anything like this, and send that to a server where we do the data analytics and the heavy data analytics part. So different this technology can basically provide different services and many benefits. We try to work mostly on continuous patient monitoring solutions. We try to use this technology to personalize things, to really tailor that for different subjects, and also predict health status. And and at the last stage, we also try to provide smart intervention and recommendation solutions. So at the end of the day, what we try to do using all these technologies, either to access, increase the access to care, and reduce the healthcare costs, which are really kind of problematic, especially in the US setting. A lot of information can be found in this article. I just wanted to share with you the role of IoT, especially in nursing and also in healthcare in general. I recommend you to study this paper. I'm not going to go through it in details, but there you can find basically a nice survey about what's going on around this topic. And another interesting paper, which basically in which you can find some of the market information about IoT and healthcare, and the fact that basically different type of solutions in this scenario is being actually offered. So especially there are three main categories that are very active in the healthcare domain. One is this medical devices. Basically, a new wearable sensor may come out, and there are basically, you see every day a new wearable sensor and so on. There are certain services and basically infrastructures to enable, for instance, researchers or developers to capture information on health-related basically information, and also a lot of softwares and systems to help you analyze your data, to help you do sense making and stuff like that. So we do a lot of medical device building, but also we focus on other aspects as well. So let me get into the actual case studies. There are 3 case studies that I want to, together with Professor Dodd, we'll touch today. We do a lot of different things actually in the lab. Sorry. Depending on different problems, faculty, they could come to us, they have different problems, for example, in hospital setting or in the community and so on. And we try to help them with different, basically, and to find a proper technology which can help them address a certain need. So in this space, we have done many different things. We have worked on a portable ICU type of project. We have worked on fall detection and fall prediction for elderly. We have worked on sleep monitoring, building a sleep monitoring device and so on. But I'm going to basically today, first, I'll talk about pain assessment. And together with Professor Dodd, we'll talk a little bit about the maternity care and the smart maternity care system that we have built. So let me first start with this pain assessment project and tool that we have been working on. This is a project which was initiated in Finland like a couple of years ago, and then continued here at UCI and UCI Medical Center. And it's about how we can objectively assess pain. So using sensors and so on. So the problem is that assessment and assessing pain is difficult, especially when the ability of patient to communicate is limited. For instance, for kids, for patients who are sedated, or those who have critical illnesses, and they cannot self-report. And the fact is that actually the golden standard of pain assessment is self-report. So what if someone cannot report their pain, for example, from the scale of 0 to 10 or something like this, right? So that's a very important problem, especially in ICUs. And we were actually, we were reached out a couple of years ago by nurses from the hospital, and they wanted to see if we can help them with building some technology. So we know the pain is subjective, but we wanted to find a way to objectively measure that, which is kind of challenging, but we as researchers, we're always looking for challenging things to do, right? That's what's called research. So there are certain possibilities to reach out to basically approach. One thing that we noticed that is there are at least 2 different ways or indicators of pain or reflectors of pain. One is basically, one category is the physiological signs. For example, your heart rate. When you are in pain, your heart rate start increasing, right? You may start sweating, or your skin temperature may change, which are all under the influence of your autonomic nervous system. So that's one category. And on the other hand, facial expressions or facial muscles, which are kind of the behavioral indicators of pain, are also very informative. And the cool thing is that even during sedation and anesthesia, they still reflect, which is interesting. So, and they, there's an increase during the painful stimuli, even during those things. So we identified a couple of actually those important facial muscles, which basically have a correlation with pain. And we tried to build a system, a facial patch, which is connected to the a body area network. And together, they measure a certain facial muscle activity, which is also called electromyograph, which is basically monitoring the activity of facial muscles. And we also monitor the autonomic nervous system parameters like heart rate variability, respiration rate, and electrodermal activity, which is the same thing as like sweating, and try to use machine learning methods and data analytics tools to do sense making and see if we can map all these things to a scale from like 0 to 10, which is actually equal to the same thing as what is used for those who can report pain. So I don't want to go into the details, but the idea was that, of course, in such situations, you need to first start with healthy subjects and you need to stimulate pain. And trust me, we had to do that. And we got the approval from our ethical committee to do that, to stimulate pain and also to measure that. So we started from a very simple, huge board to build a system for that. Then we made our own printed circuit board and basically collected data. We had to stimulate pain using two different ways, basically using electrical pulses and also heat. Of course, there was a very safe procedure for that, but the results, our first preliminary results show that actually we can separate pain and we can identify different pain levels. And we published some papers on that. So we had 15 males, 15 females, and this is what we achieved for and using certain artificial neural networks to be able to distinguish. It shows that this is a promising solution. And then actually we started to really go to hospitals and deal with real patients, especially the post-operative patients. We have also built a very first kind of prototype, if you will, of the patch. It's nothing complicated, but it's a proof of concept. And now we are planning to, with the help of CalIT2 and Professor G.P. Lee, hopefully in the future, to build a more advanced and disposable and low-cost version of it. But just wanted to show that this is a very good example of IoT because there is a wearable sensor, there's Bluetooth and Wi-Fi communication. We have two different versions. The information is being sent to the cloud and data analytics are done remotely and the results are sent back to bedside for the patients. And the cool thing is that we could even distinguish between frowning and actually a real pain expression, which means it shows that you cannot easily fake pain by just frowning your face. This shows a little bit of our backend, the internet side of this IoT solution, where you could log in and see all these signals and so on. And these are a little bit old slides, but we are now trying to use a similar technology like this to build a low-cost patch for this and hopefully test it again in hospitals. So currently in two different hospitals, one in Finland and one at the UCI Medical Center, we're testing this, we have collected new data and we're trying to now analyze that and hopefully soon new papers will be out regarding our results. We have had some promising results. All right, that was the first case study. Let me now go quickly to the second case study, which is about monitoring pregnancy and we overall call it family-centered monitoring in pregnancy, in maternity care. It's about empowering women to do self-management and take care of their health, especially to keep them healthy, like to encourage them to do more exercise, to be able to monitor their stress and provide them with certain like stress reduction techniques, and in general support them in their basically in their houses in a remote way. So as usual, when you want to do such a research, you need to start with a very small feasibility study to see whether it's feasible, whether people are willing to even wear such things for 8-9 months. It's a pregnancy. It's not like a week of monitoring. People need to really adhere to that. So we ran a small scale, like 20 subject feasibility study, but for about 8 months, which was like 7 months during pregnancy and 1 month after delivery. And we monitored, basically we gave at the first phase just a small wristband to our pregnant mothers, and we monitored their physical activity, their heart rate, their sleep, and a bunch of other things. So we had 20 pregnant mothers, as I said, for 8 months. We monitored these 3 things continuously. And we interviewed them to see whether they're willing to, wear this for quite a long time. And also we had access to their medical records, like their, because every couple of weeks these mothers visit a clinic and certain measurements are done, like their blood pressure and certain other things. So we had access to those things as well. So we had a very diverse population, some with high BMI, some with gestational diabetes, smokers, low socioeconomic status mothers. Some of them were really kind of single moms, and some had unplanned pregnancies. And even such a small study, I just want to show you the power of IoT and what you're doing in your internship. It's really a powerful thing. We had a very simple wearable, a small number of people, and we ended up having 4,000 days and every minute data for 4,000 days in total, which is a huge data. And we're not even talking about a huge population. And we had parameter data of their heart rate, their resting heart rate, their sleep quality, like the deep sleep part, the REM sleep part, how many steps they have had, how intensive their exercise, their activity was, for instance, and that's usually calculated based on the heart rate elevation and many other things, which actually helped us to make some new observations. For instance, we noticed that the resting heart rate of these pregnant mothers is basically increases by 16% from the week 13 and week 32. It's both the resting heart rate, mean heart rate, and maximum heart rate. And then for the rest of their pregnancy, it stays at the same level. There were evidence showing that before, but no one had such a fine-grained data to really prove that in a very robust and reliable way. We also looked at the physical activity of these mothers, and we noticed that depending on the trimester, which trimester they're in, this physical activity is decreasing, which is not a good sign. Of course, it's expected, but it's not recommended. You want pregnant mothers to stay active, to have a healthy pregnancy and healthy kid. So they recommended a duration of physical activity based on ACOG recommendations is about 150 minutes of moderate intensity activity per week or 75 minutes of vigorous intensity. So, but what we observed was that, okay, we had a small sample size, but what we observed was that during the second trimester, on average, 46 minutes of moderate, just compare this 46 minutes to 150, which is a recommended. Third trimester is even lower, and postpartum, meaning like after pregnancy, it's about over 15 minutes. This shows that actually the physical activity level of pregnant mothers is not sufficient, and that's a problem. And actually, you will see that Professor Dodd is going to present a solution that now we are presenting to cope with this issue and help mothers to keep and stay active. And that's part of our ongoing project that Professor Dodd will basically present. So regarding the feasibility aspect of this, we wanted to see also the wear time, if the pregnant mothers are willing to really wear it for a long time. And we did not provide any incentives to them for this. So actually that was something to really see if they're willing to do that or not. And the average was kind of 163 days during the 7 months, which is a good result, showing that this is something that people like. They just didn't take it off. Of course, this the rate, there was a decrease over time, especially in postpartum, because some mothers were kind of were concerned whether the wearable may scratch their kid when they're hugging he or she and so on. So there were certain issues, but overall, the wear time, the average wear time is good. It's about 18 hours, and we need to consider the fact that these wearables need to be charged, meaning that you will never reach 24 hours, because anyway, they have to take it off every now and then and charge. So the conclusion is that these smart devices are feasible to monitor health data, and that's why we basically kicked we kicked off a very large NSF project together with Professor Dot and a group here at UCI. And I guess Professor Dot will present the rest. Any questions for me, especially before? I'm sorry that I have to leave, but I would be happy to take questions. Okay, if not, maybe Professor, I can maybe stop sharing, and if you want.
Sure. Let's thank Professor Ramani for a really excellent introduction and a detailed look at a couple of projects. So he's going to hand over to me, since I understand he has to go for a faculty meeting during the summer.
Can I ask a short question?
Sure.
So, Amir, thank you for a very, very interesting talk. I have a question is, most of work in IoT is about sensor data acquisition. And is there any current activity in health delivery at the IoT platform?
Well, we are you asking in our group or overall in general?
In general, so instead of just collecting data, is a sensor actuator, right? So to act upon, to help people. I know it's a rehab area, there are devices, but other than rehab, any other work for the delivery side?
Actually, that's a good question, and thank you for raising that. The thing is that in many of the IoT solutions, the actuation is usually happening through a human in the loop or through recommendations, which are kind of virtual actuations. For example, we are developing an app-based intervention, which basically, like Professor Dao will talk about that, it recommends, actually it provides certain instructions and recommendations for a mother on how many iterations of an exercise they need to do, what kind of exercise they need to do, or we provide mindfulness, for example, mindful breathing exercises that they just look at our mobile app and they try to follow certain things and to have stress reduction. But I think what you're referring to is mostly like the physical actuators, which like in rehabs people are using. We haven't done that much of like a physical actuation. We had mostly like M-Health, like mobile health type of solution, or smart recommendations where we send certain things like please do this, please do that, or we provide information to a nurse in the loop, and that nurse will go through and do through home visitations, basically, walk people through the activation. So I would say there is a little bit difference here between like this maybe CPS or cyber physical system style rather than like IoT. In the IoT part, the actuation is a little bit more relaxed, sometimes even virtual.
Thank you.
I have a question about the fabrication of the device itself. So I apologize if I missed it, but you had a polyimide layer and you had, I'm assuming, a flexible PCB. Mm-hmm. Okay. And did the flexible PCB already have the wires, or did you have to etch it on there, or did you like apply an ink, or what was that process like?
I would say Professor Lee is the best to answer that, because that's basically what we are collaborating with Professor Lee. But in short, one of the technologies that we used back in Finland was printed electronics. When basically we were printing on normal substrate, like a photo transparent substrate, the inks were like silver, wires, and using basically inkjet printed electronics. But Professor Lee is an expert on this topic.
I think we can discuss that offline. There are many technology we have developed at the UCI, and it can be made available to researchers at the UCI.
Okay, nice. Thank you. Thank you.
Welcome.
All right, guys. See you.
Thank you, Amir. So I'm going to take over and just
thank you, Amir.
Start from where. Whoops. Why am I not allowed to do that?
Are you not allowed to?
It's not allowing me to share computer for some reason.
Okay, I just made you a co-host, Nick.
Okay, maybe it'll work now. I'm still seeing nothing. That's bizarre. I'm seeing, when I hit share screen, first time I'm seeing this, I'm just seeing, you know, sharing blank screens on desktop. So that is bizarre. Okay. Let's see. This is really bizarre.
Because you should be able to share as a co-host.
Yeah, this is the first time I'm just seeing nothing. I've done literally hundreds of Zoom calls so far.
Yeah, I know.
This is bizarre. Okay. Right. I may just end up having to talk if not anything. If I maybe email, I don't know if this will work, but if I have to.
Do you wanna email it to me and then I can open it?
Let me do that. Let me do that. It's a big file, but this at least we can do that. So
there's an option to allow all the everyone who's viewing to share their screen. On the bottom, you can go to share screen. There's an arrow. You can click on it, and then there should be an option to allow everyone to share.
Yeah, I have that.
okay, I'm just sending that over to you, Said, if you don't mind. Okay, it's 40 megabytes, so it's a little big, but there, hopefully you get it. So while we're waiting, so I think just picking up on what Professor Lee was asking, you know, the classical model of IoT that we think about is that we're sensing information and we're making some sense out of it. And if you think of what we talk about in a cyber physical system, that's where you not only have the sensing aspect, but you close the loop with actuation. So in a control system, for example, if you're looking at an industrial plant or an aircraft or any kind of engineered system where you have a computing engine inside that's gathering information from the environment, making some sense, and then actuating and closing the loop. And so far in healthcare IoT type of systems, the closing of the loop typically has been done by humans in the loop, mostly. And the human might be, for example, might be the patient or the individual. For example, a recommendation back to you as the human to say, maybe eat better or take more steps or make sure you avoid alcohol or whatever else. Or it might be an expert. It might be a nurse or a doctor or a physician who has more knowledge so they can get the sensed information and look at the sort of assessed information and provide recommendations back to the human. So far, that's what you've seen in a lot of what you might call as healthcare situation. Of course, you can look at engineered medical devices, and there you're actually closing the loop. So if you have a smart insulin pump, or you have some other medical device that actually not only senses, but actually actuates. So you do have those as well, but those are typically more for medical devices. But if you look at larger healthcare systems, I think what you typically see is more of the human in the loop or an expert in the loop in terms of how you do the actuation. Said, any luck?
I haven't received it yet.
Oh, it's a huge file. So what we've been doing, I'll just talk through that, and if you get time, we can do that since we don't have too much time. But so Professor Ramani, you know, he had done quite a bit of work in Finland. When he came here, we started collaborating. And based on the preliminary work he had done with looking at pregnant, you know, trying to help with the health of pregnant women, we applied to a very large National Science Foundation program called Smart and Connected Communities, SCC. As you all know, the National Science Foundation is an entity that's looking at basic science. So the mission is to advance basic science. But increasingly in the last few years, they've also started looking at large programs that take the basic science and see how it can impact society. So you can actually see maybe in a near term, how those basic science concepts can be used to help humanity in general and communities in general. So this program called Smart and Connected Communities is focused on looking at using technologies to help communities in general, which might be smart cities and things of that nature that you think about. What we decided to do was to take these ideas and see how we can help with underserved communities of pregnant women. And so we were focused on looking at helping underserved pregnant women in the Orange County area. Now, you might expect Orange County is very wealthy in general. If you don't live here, you don't know that. Of course, there are segments of the society that are underserved and actually economically disadvantaged. So if you can jump to slide 32, that'd be great. Thank you. So we applied for that program, and we were fortunate. It's a highly competitive program, and we were lucky to get funded. It was a very highly rated proposal, and we kicked off the program about 2 years ago. So this is, can you go to the next slide, please? So just for the context, it's the Smart and Connected Communities effort from NSF. Next slide, please. And as I mentioned, the mission of that proposal, of that program, is interdisciplinary integrated research, which actually does and undertakes meaningful community engagement. That's what you see highlighted at the bottom. So next slide, please. So what we did was we took this model that exists today in many communities. It's a model where there are many nonprofit agencies in communities that help underprivileged and underserved women in terms of healthcare. So if you could go to slide 35, thank you, yeah. Go back one, please. So in this model, what happens is because these women may not have ubiquitous access to care, there's a model where they train paraprofessionals trained by nurses to go into the homes of these women, maybe every so often, perhaps once a month, or maybe more frequently, depending on how that goes, to see how they're doing, talk to them, give them more information, and then report back to nurses or trained professionals to sort of maintain the state of the women and help them sort of monitor what they're doing. And this is in addition to doctor's visits that they may be doing every trimester, or in some cases, maybe they don't even have insurance. So this model has been very successful, and the specific organization called Moms Orange County had piloted this home visitation model, which is very successful for a number of years. Now, what you can see in this model, although it's successful, is that the moms are maybe in contact with paraprofessionals just maybe once a month, if they're lucky. Next slide, please. So what we thought we could do is the power of IoT is that you could see before that if you're able to monitor the health state of the mother, what you see in the blue is the traditional model. And what we could do is the green is what you can see in terms of trying to have an IoT infrastructure, which allows us to monitor the state of the moms and build recommendation systems that could go back and close the loop to either the moms to help them maybe do better things in terms of their lifestyle, and or monitor and then provide feedback to nurses and doctors so that they can actually keep track of these mothers. So you can see on the left-hand side, the bullets show you that the Unite model, this project called Unite, has wearable IoT monitoring, WIoT monitoring. And it incorporates, as we discussed, it incorporates a registered nurse in the loop smart intervention. So this harks back to Professor Lee's question. So we actually have an expert in the loop who can actually provide intervention. Intervention would be recommendations for what they should do. And there's a significant amount of community engagement and self-management in this project. So next slide, please. And it's a very ambitious project. So this petal chart that you see here, you can see in the middle, the most important thing is the underserved community of pregnant mothers in the middle. And traditionally, there was this Mom's Orange County model, which was the home visitation model. And we're building on top of that an infrastructure, a wearable IoT infrastructure with smart interventions that actually is multidisciplinary. We have partners from nursing, from education, from the medical center, from psychology, as well as from CS and engineering. And then we have an advisory board of different agencies that help us and guide us in terms of how we do that. Next slide, please. So this slide you've seen in passing before. This is kind of a traditional three-tier architecture that Professor Rahmani talked about. So on the left-hand side, you see the mothers wearing these sensors. In this case, it's a combination of a smart watch that you see here and a ring that I'm wearing here, which monitors different things, including your heart rate, including heart rate variability and contextual information. And then in the middle, you have the smartphone, which acts as a gateway and also provides the ability for the moms to actually use apps and interact with the apps. And on the right-hand side, you have the cloud. So a very classical three-tier architecture. And then what you see at the bottom is the feedback that you can see, where you can go back and then give recommendations back to the mom via the watch or through apps that we have developed. So next slide, please. So we don't have too much time, but I'm just going to zoom over this very complex picture here. And this is kind of the heart, the technical heart of what we're doing in this project. And what you can see in pink is observations and data that we're collecting from the mother, which includes, for example, observations, GPS, heart rate, et cetera, et cetera. And through that, we can do some mining of specific information. For example, we can look at the health activity. And together with this yellow box that you see here, which is a personal model of the mom, we can establish the real state of the mother. And what you see in light green at the bottom is sort of what we want to do, where we want this mother to be. And this comes from, for example, the healthcare provider, who might say, if you're at a certain stage of your pregnancy, you should be taking so many steps a week. Or your diet should be following this kind of model. Maybe you're having too much sugar or whatever else. So there's this light green box that says desired state. So what we're looking is combining this real state that you see in pink with the light green desired state, doing a diagnosis, doing cause assessment, and then building these sophisticated recommendations. And these recommendations can go back either to the mother, that you can see in the top loop, which says recommendation back to the mother, and also to build the model, because we're updating this personalized model of the mom, as well as at the bottom, you can see this report that goes back to the healthcare provider. So this is how we're closing the loop in this wearable IoT infrastructure. So it's fairly complex, but what I want to share, next slide, please. So it's a very interesting, exciting project with a lot of moving parts, very, very exciting project. And one key thing that we have been developing is this app called Two Happy Hearts. You can see in this picture here, the mother and the baby. And it's an exercise and mindful breathing app that we've developed that actually incorporates recommendations for the mom, depending on what phase of pregnancy she's in, depending on her health state, how active she's been. It recommends the right level of exercise. And if they're stressed, it recommends them to do mindful breathing so they can reduce their stress level. So we're at a very exciting point in this project where we're at the point where we're doing a feasibility study of this Two Happy Hearts app. And we're in the process of building personalized models. And our surf-IoT participants are actively involved in different aspects of looking at the Android development in terms of data collection, in terms of web-based apps and so on. So that's kind of a quick snapshot of the project. I apologize, we didn't have too much time to get into detail, but I do want to save a few minutes for questions. So next slide, please. So I'll stop here and take questions.
Thank you so much, Professor Dutt. Please turn your cameras on, and I want to invite all your questions. And Professor GP Lee sends his apology to you, Nick. He had to leave to another meeting.
No worries.
Um, so, any questions?
I have a quick question that I could ask.
Yes.
So currently considering that there is the pandemic throughout the country or throughout the world, and that I'm assuming that there would be difficulties with getting registered nurses, like getting them to be able to visit safely and consistently with patients. Has there been steps to try to modify either like the Mom's OC loop or just the entire loop to be able to accommodate for that? Or has it just been kind of figuring it out?
Aviv, you've sort of hit the nail on the head. This is exactly why this Unite project makes so much sense. Because, in a traditional model, even if we didn't have the healthcare workers going to the homes, there's still a need for these moms to see nurses on a regular basis, right? So the idea is that with this kind of technology, we can actually make it a little easier to monitor the health state of the mothers. And even though they cannot maybe physically monitor the mom, you can actually elevate the level of interaction with the moms on a more regular basis. And most importantly, you can flag any early warning signs early without, sort of on demand, right? Because if you see that if the heart rate is going up very, very high and it looks like the mom hasn't been exercising vigorously, which we can detect through activity detection, then that tells you that's the cause assessment. And then that can flag a trigger, an abnormality that'll trigger maybe an interaction with a nurse or ask a medical provider to intervene. So yeah, actually, if anything, this pandemic has created a more urgent need for this kind of technology. And related to that, we had to deal with things like, well, this sounds good, but how do you get stuff out to them? How do you actually interact with the mothers, right? How do you recruit them? So we're in the process of developing protocols where we can recruit mothers, we can safely ship them these watches and rings, and then we have to spend more time in Zoom calls or little handouts that say, here are the steps involved in how you use the watch and use the ring and stuff like that. So we're in the throes of exactly that in terms of how to operationalize this project. So thank you for that question. Yeah.
Thank you.
Melinda, I can bet you have a question or a reaction to something.
I don't have a question, but I thought it was very interesting, like talking just about IoT in general and just, how it can, I really thought the application that you're currently testing the feasibility on, the 2 happy hearts, I thought that's very interesting to see how you can apply the research you're doing now into something that can be more widespread for people to use. So yeah, thank you for the presentation today.
Thank you. Yeah. And, I forgot to include the website, but if you're interested, you can go to unite.ics.uci.edu for more details on the project. I should have done that. So, or a QR code. But, again, we're almost out of time here, but if you have any questions, feel free to reach out to us. We'll be happy to chat some more. And as I mentioned, this project is now at a phase where we're doing, just as you heard, the feasibility study that Professor Rahmani had done with wearables. We're doing the feasibility study for the 2 happy hearts. And we're going to be recruiting between 20 to 60 pregnant mothers in the coming months to do an observational study for a few months. And then we'll get into a randomized control trial where we actually try and build the recommendation system and deploy it in a much larger scale. So that's where, so the project is actually a combination of both basic technology and also application to see how it might actually be deployed for societal good. That's kind of
Nick, if you would allow me, if you have time, I just want to take.
Yeah, please go ahead. Yeah.
So the application and the entrepreneurial side of this.
Yeah.
I mean, I could see electronic jewelry, loving the concept, and they want to build some products out there. What other potential do you see for for this to go in the market?
Yeah, I think there's depending on what kind of project you're looking at, there's tremendous potential for on one hand commercial viability, on the other hand for societal good, and sometimes those are at odds with each other, as you might expect. So the Unite project, for example, is really about trying to look at as much as possible. We want to reduce the cost and increase participation, right? As opposed to if I were to build a nice shiny bauble, IoT bauble, medical grade something that's it's a little bling on the ring, and then it's a very high end maybe for athletes or something else. That's a different market. But I think the basic technologies are still there and deployable in different contexts. So the short of it is, depending on, for example, Professor Lee knows about that. We had written a fairly large proposal to NSF, and now we're pivoting to NIH for the pain assessment. So that's where we might be looking at a commercial acceptability of a patch, low cost patch that people can use. And we know that pain is actually a very large market worldwide, right? People suffer from pain, chronic pain, there's all kinds of pain. So that is a huge market in terms of how you can help with people to manage the pain. So that's one example where things that we do in the lab have a great potential depending on the market size, depending on the segment that we're going to be looking at, and how we deliver these services, right? So on one hand. So there's, we did actually file a patent, by the way, for this pain patch through UCI. So that's also, in the works in that direction. Yeah.
Congratulations again. And you always do wonderful things for all of us and for society in general. And we're grateful to you. Can we give a hand to Professor Dutt and also Professor Rahmani, please?
And again, thank you all, especially all the surf-IoT interns. You guys are hanging in there. I know it's been a really hard summer with COVID. And those of you in Northern California, please stay safe. Yeah. And I hope everything goes well with everyone. Okay.
Thank you, Professor Dutt. We
care.
wish you all well.
Yeah.
Have a great afternoon.
Take care. Bye-bye.
Take care, everyone. Bye-bye.